Hey kids, this video is going to go over the quiz review. Here are the problems. You should have had them down already. Let's go ahead and get started with 4-4. Questions 1 and 2 are very much the same. Identify any congruent figures in the coordinate plane and give an explanation. Here, if you're going to give an explanation, kind of justify quickly, and I emphasize quickly, don't give me a huge paragraph here. Justify quickly the congruence transformation that would need to occur from one to the other. So you can probably see that this rectangle here, rectangle 1 and rectangle 2, notice if you want to go from 1 to 2, you just have to move right and then down. So if you wanted to explain it, 1 and 2 are congruent to each other, and say it's a translation away or something like that, something really, really quick to justify that, yeah, you can make rectangle MNPL directly on top of EFGD, for instance. Let's see what other shapes are congruent. I'll leave the 1 and 2 there, probably for good measure. And it looks like 3 and 4 are probably congruent as well. And it looks like if we wanted to rotate QRS 90 degrees counterclockwise, that we'd probably get there. And recall, not necessarily with this problem, but you do need to know all of these rotation rules. And so rotation 90 degrees counterclockwise. Remember, the rule is AB goes to negative BA. All right. And so in this case, notice the point, for instance, 4, 2 would go to negative 2, 4, for instance. So, and notice that looks like K matches up pretty well with S. So I'm guessing that all of those points would match up pretty well after a 90-degree rotation. So not only are you saying they're congruent, but you're giving me a very brief explanation as to what you would do, what would be your congruence transformation to go from one object to the other. And in this case, it doesn't matter if you say go 1 to 2 or 2 to 1. It doesn't really matter because the problem doesn't really require mapping one to the other. And it looks like these two triangles are not congruent to each other. Notice that this goes 1 unit to the right and then 3 units to the right, whereas this goes 2 units and 2 units. So watch out, those two triangles down low are not congruent to each other, but the rectangles are, and the little triangles up top, triangles 3 and 4, are congruent as well. Question number 2, it looks like triangle 1 and 2 would be congruent. And again, I think that would be a rotation. If you wanted to rotate to 90 degrees, I think you would get there. It looks like these rectangles are congruent. Let's call them rectangles 3 and 4 are congruent to each other. And again, you could say a quick, as a brief explanation, say I translated right however many and down however many. So you can see that this triangle on the left, or excuse me, rectangle on the left would be exactly on top of the rectangle on the right. And let's look at these triangles. This triangle has a side length of 3 and a side length of 4. This triangle is a side length of 3 and 3 for the upper right one, 3 and 3. And this one is 3 and 4. So these two triangles in the upper right and upper left will not be congruent. They're not the same size, nor are they the same shape for that matter. They're both triangles, but they don't have the exact same look to them. So those two triangles would not be congruent. It would just be triangles 1 and 2, and then it would be rectangles 3 and 4. And again, just give me a brief explanation here. Now, here's where we're gonna have to do more specific explanations. Okay, I'm gonna want to see step 1, step 2, step 3, etc. And so in exercises 3 and 4, describe a congruence transformation that goes from blue to green. Notice we're going to take the blue and move it to on top of the green. That's the goal. Don't take the green, move it to the blue. If you did, I would give you most of the points, but not all of the points, because it does say go from blue to green. And so I'm thinking here, they definitely look congruent, but they're definitely oriented the wrong way. And so I'm thinking step 1 here, we're going to want to reflect over the y axis. Okay, so this point will go here. There's C prime, here's B prime, and here's A prime, Duke, Duke, Duke. Okay, if you would like to label them, go right ahead. Here's C prime, here's A prime, and here's B prime. And then it looks like if I reflect it over the X, now I have at least a correct orientation. I'll go ahead and change to red. Here's C double prime, here's A double prime, and here's B double prime. And then it looks like I have to just translate it. Left 1, 2, 3, 4, 5, down 1, translate. And I'll say XY goes to, so again, it was left 5, down 1, so it's X minus 5, comma Y minus 1. All right. So notice here, compared to questions number 1 and 2, I was much more specific in my arguments. All right, and that's what I'm going to want to see. If I say describe a congruence transformation, I want you to be spot on. Okay, so reflect over the y-axis, reflect over the x-axis, and then translate left 5 down 1. There might be another way to do this, and in fact, I'm sure that there is another way to do this, but this argument would work just fine. Anything that is good, I'll make sure you get credit for. Number 4 is the same. Now we're still going blue to green. And what are you thinking here? I'm thinking this might actually be a rotation. This looks like a rotation of 180 degrees. Okay, let's recall 180 degree rotation. And again, remember these rules. I think AB goes to negative A, negative B. So let's see if this works out perfectly. R is at 1, negative 2. So that's going to go to negative 1, positive 2. So R prime is in fact Y. We're good there. S is 5, negative 2. It's going to go to negative 5, positive 2. So that's Z. Q is 3, negative 4. So it's going to go to negative 3, positive 4. That's X. And then P is 5, negative 4. That's going to go to negative 5, positive 4. And that is W. So here, it's only one step. 180 degree rotation. Not too bad. There's probably other ways you could have done it. If you wanted to reflect over the x-axis and then reflect over the y-axis, that would be another correct answer that I think would work just fine. But here we see that 180 degree rotation would work as well, and then you only have to do one thing instead of two. Number 3 probably could have done something similar. If I had rotated 180 degrees, it may have worked quicker than doing a reflection over the X and a reflection over the Y, but I just didn't notice that. And it's fine if it takes you 2 steps or 3 steps or 4 steps. As long as you do it correctly, I'm happy. So no big deal. Numbers 5 and 6, I'll plot them both. After I do number 5, I'll erase it, and then I'll do number 6. So the question is, are these congruent? And if they are congruent, then use the transformations. Do basically the same thing we just did in 3 and 4. So here's Q. It's 1, 2, 3, 4. There's Q. R is 5, 4. 1, 2, 3, 4, 5, 4. And S is 4, 1. 1, 2, 3, 4, 1. So here is Q, R, and S. Little triangle there. And let's change to blue. T is 6, 4. 1, 2, 3, 4, 5, 6. There's T. U is 9, 4. And V is 8, 1. Do those triangles look congruent to you? They certainly do to me. How could I argue it? So that's definitely yes. I'm going to say translate right 4. All right. If I pick up and move the red one 4 units, 1, 2, 3, 4, everything is going to match up perfectly. Okay. So you could say translate xy goes to x plus 4 comma y. That would do it. That's sufficient in this case. Only one transformation required. Let's go ahead and erase this and do question number 6 on the same grid. Here's W. Let's start in red. -3, 1. It's W right there. X is 2, 1 right there. Y is 4, -4. Let's slide down a little bit. 1, 2, 3, 4. 1, 2, 3, 4. And then Z is -5, -4. 1, 2, 3, 4, 5. 1, 2, 3, 4. So we have a trapezoid looking object here. And it's W, X, Y, and Z. And let's change to blue. C is -1, -3. 1, 2, 3. And D is -1, 2. So that's C. That's D. E is 4, 4. 1, 2, 3, 4. 1, 2, 3, 4. And F is 4, -5. 1, 2, 3, 4. 1, 2, 3, 4, 5. Students are entering that they're going to be allowed. All right, so here we go. These shapes do actually look the same. You can do a quick measurement here of these sides just to be sure. For instance, this length is 1, 2, 3, 4, 5. This length is 1, 2, 3, 4, 5, for instance. This length is 1, 2, 3, 4, 5, 6, 7, 8, 9. This length is 1, 2, 3, 4, 5, 6, 7, 8, 9. Can we be quiet, kids? I'm making a video. Thank you. That may have been somewhat obvious, but okay. So they will be quiet now. So it looks like we have congruent figures, and so our plan is to translate or transform one to the other. Okay. It definitely looks like we're going to need to do some kind of rotation here of one of these objects. Let's start with the red. The red was the initial shape, I believe it was. So let's go ahead and say step 1 here. Looks like if I rotate red 90 degrees, that should work just fine. And again, remember, AB goes to -B, comma A, would be a 90-degree rotation. So let's change to green and do each point individually. W is at -3, 1. So I flip-flop. Now it's going to be at, so it's -3, 1. We'll go to -1, -3. This is going to be W prime. Well, that lands on C. That's good. Z is -1, 2, 3, 4, 5, -5, -4. Do the 90-degree rotation. We get 4, -5. 1, 2, 3, 4. 1, 2, 3, 4, 5. This works again. So I think we're going to be good to go. That's going to be Z prime. And let's check Y. Y is at 1, 2, 3, 4. 1, 2, -4, 4, -4. That will go to 4, 4. Right up there. That is going to be Y prime. And let's check on X. X is at 2, 1. I do a rotation, -1, 2. There we go. There's X prime. So all I needed to do was a 90-degree rotation. They were congruent. After 90-degree rotation of the red ends up right on top of the blue. We are good to go. Life is fantastic. So that's section 4. Let's talk about section 5. Now we're talking about dilations, okay? And when we talk about scale factor, remember, scale factor is always not old length. New length divided by old length, okay? If I started out with a length of 2 and I ended with a length of 8, the scale factor is 4 because 8 divided by 2 is 4. New divided by old. So question 1, what's the scale factor? Well, the old length is 14. The new length is 6. So K is new length is 6, old length is 14. 6/14 is my scale factor. Notice this number is less than 1, so this is going to be a reduction. Number 2, new length looks like it's 24. Old length looks like it's 9. Okay, again, it's new over old, so it's 24, ninths for the scale factor, okay? And in this case, this is an enlargement. No big deal there. Question number 6, center point P, K is 3. So what we're going to do is we have to draw the rays, right? Here's P to M, and I'll make it fancy schmancy. Here's P to M. But K is 3. So I want to keep going in the exact same direction on the same ray, but I want 3 times the original length. So I'm going to make 2 copies of this. I'm going to clone it once, and I'm going to clone it a second time, just to make the drawing nice and neat. This would be K equals 2. This would be K equals 3, all right? Scale factor of 3. So my M prime is right here. It's on the same ray, same direction, but it's 3 times as far away, all right? L is going to be a little bit ugly, but we'll make it work. Let's change it to the blue. Okay, since we're going from P, let's do infinite cloner. This would be K equals 2. This would be K equals 3. 3 times as far away, pretty close. And we'll call this L prime. And then go from P to N. Do the red guy. And again, all infinite cloner. Perfect copy here. This would be K equals 2. Perfect copy here. This would be K equals 3. Something like that. And this would be my N. Is that N prime? And then you go boom, boom, boom. Okay. Not too bad. Not too bad. So there you go. That would be number 6. Let's do number 7, kind of erase what we did here. I only have the picture drawn once. Now in number 7, notice the center point is M. And notice the K is less than 1. And so what's going to happen is it's going to, point M is kind of going to be the tractor beam here. It's going to pull everything closer to it. So point M is actually going to stay put. This is going to be M prime, right? That's what always happens with the center of the dilation. And now you're going to go towards point L, but you're only going to go half the distance, all right? That's what K being 1/2 is. So right about there, this would be L prime. And again, you're going to go on the path to N from M, since M is a center point. But again, since K is only 1/2, you're only going to go half the distance. So this right about here would be N prime. Boom, boom, boom. There you go. Okay. That is how number 7 works. Everything's being pulled towards M since K is less than 1. If K were greater than 1, everything would be going away from M. You'd be expanding from M, but in this case, you're contracting towards M is the idea. Number 13, graph the polygon and the image after dilation. So let's see on this little graph down here, 6, -1, 1, 2, 3, 4, 5, 6, -1. Y is -2, -4. -2, 1, 2, 3, 4. Maybe let's go full screen here. Might make it easier. And then Z is 1, 2. And they want a scale factor of 3. All that means is multiply every single number by 3. So in this case, it'd be actually kind of annoying to draw it because I would be going off of the page. Let's just do it numerically here. X prime would be 18, -3. Looks like Y prime would be -6, -12. And then Z prime would be 3, 6. Again, all you're doing is multiplying all of those components by 3. All right. In the quiz, everything will stay on the paper. You'll be good to go. This is just a little annoying to draw those out because of the big numbers. 18 is kind of the same way. K being -3. Again, you would make it bigger, okay? But now you're going to go in the opposite direction of the ray, the direction the ray initially went. So again, let's just find these points here. L prime would still be 0, 0, because 0 times -3 is still 0. M prime would be 12, negative 3. And N prime would be 9, 18. Okay. No graphs are really needed on that. And if you had to graph it, you can plot that very easily. I know that you know how to do that. So that's dilations. Not too bad. You would still see this arrow stuff going on if you drew those in, if you drew the original and then the image. Okay, you would see the arrow relationship occurring. In this case, for number 18, you would see the arrow going in the opposite direction because of the negative k value. In both cases, you'll be making the object bigger for 13 and 18, but for 18, you're going to go in the opposite direction. And let's do section 6. Now we're talking about doing these similarity transformations. Notice they both have dilations, not surprising. And so let's go ahead and plot this. F is negative 2, 2. Let's go enough. There we go. F is negative 2, 2. And G is negative 2, negative 4. 4. And H is negative 4, negative 4. 1, 2, 3, 4. 1, 2. Little right triangle here. Step 1 is dilate. Notice here the K is 1/2. So all you're going to do is multiply all of those components by 1/2. So F was at negative 2, 2. Now it's at negative 1, 1. There's F prime. This was G over here, negative 2, negative 4. So now it's negative 1, negative 2. There's G prime. H is at negative 1, 2, negative 4, negative 4. So now it's negative 2, negative 2. That's my H prime. Duke, Duke, Duke. Notice it's gotten closer to the origin. Half the size, well, not half the size. The lengths are all half of the length that they originally were. And then we're going to reflect over the y-axis. And remember, in this case, that means AB goes to negative AB. Okay, you're changing the x coordinate. So here would be F double prime. This would be G double prime. And then this would be H double prime. Boom, boom, boom. And there you go. Not too bad. But again, you got to remember these rules. You got to know your reflections. You got to know your rotations. All right. They're on there. You have to know them. All right. Let's see here. 90 degrees about, I should have left it. Let's leave the original here. Be careful about how I erase. Not going to happen. Whatever. Let's start in black again. It is F is negative 2, 2. And we've got G is negative 2, negative 4. And H is negative 4, negative 4. All right, 90 degrees about the origin. There's that 90-degree rotation again. We're going to say, again, AB goes to negative BA. Let's plot that in green. So F is negative 2, 2. So F prime will go to negative 2, negative 2. That'll be F prime. G is negative 2, negative 4. That will go to 4. Let's see, negative 2, negative 4. We'll go to 4, negative 2. 1, 2, 3, 4. Negative 2. This will be G prime. And then H is negative 4, negative 4. That will go to 4, negative 4. And there's our 90-degree rotation. Looks about right. And then we're going to dilate by a factor of 3. So we're just going to multiply all the components by 3. F prime is at negative 2, negative 2. So that's going to go to negative 6, negative 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It's going to be F double prime. G prime is at 4, negative 2. So it's going to go to 12, negative 6. Here's 12 out here. Negative 6. 1, 2, 3, 4, 5, 6. G double prime. And then H double prime is going to be at 12, negative 12. It's 4, negative 4. So it'll be down here somewhere. And we get Duke, Duke, Duke. There we go. Okay. Notice it's a similarity transformation. The original is not congruent to the image, the final image here at the end. All right. Let's talk about number 6. Describe similarity transformation that maps the blue to the green. So I want to go blue to green, blue to green. I'm thinking let's do a dilation first. Okay. And we'll see where we go. Let's go with dilation. Always specify the center. Centered at the origin. That says origin. Doesn't really look like it. And let's figure out what that K should be. Well, we're going from big to small, right? Blue to green, big to small. So let's figure out these lengths. This length is 1, 2, 3, 4, 5, 6. This length is 1, 2, 3. To go from 6 to 3, what do you need to multiply by? A half, right? By a half. Cut 6 in half, and you're going to get 3. So let's see here. K is going to be 1/2. So let's multiply all these components by a half and see where we get after that. Let's do that in red. All right, so M is at 0.2. Multiply those by a half, you get 0.1. J is at 6.2. Multiply by a half, you get 3.1. K is at 6.6. Multiply by a half, you get 3.3. And L is at -2.8. -1.4. Duke. And that looks like all you got to do is reflect over the Y. Now that red guy will look just like the green guy. Okay, and that's not a colorblind joke. That's actually true in this case. The red one would look just like the green. So we needed to dilate first. That seemed reasonable. We saw that there were a half double relationship from green to blue. So we needed to multiply by a half. And then all we needed to do was reflect after that. So it worked out pretty nicely. And reflect over the y-axis. And final question. Let's do a little proof here. And again, as long as you talk about the transformations, I am happy. I'm trying to show that the rectangle on the left is similar to the rectangle on the right. And it looks like we're going to do step number 1 first. Translate so that M prime is T. So now we have a rectangle kind of sitting here like this. Okay. And the goal here is to come up with some kind of, probably going to be a dilation, right? What kind of dilation is required to make the red rectangle the same as the big black rectangle, TQRS? Well, it's definitely going to need to be a dilation. But now remember, if you say dilation, you should give me 2 pieces of information. Where's the center and what's the scale factor? In this case, since T and M prime are set and we don't want them to move, let's make the center centered at T. Makes sense. What's my scale factor going to have to be? What's my scale factor going to have to be? What's the new length? 2y. What's the old length? Y. What happened to the y's? They cancel. Isn't this going to be a scale factor of 2? 2 times y is 2y, right? Same thing for the x's. What's 2 times x? Well, 2x. Okay, that's what a scale factor of 2 does. It's going to double all of those lengths. So this is going to be dilation centered at T, or you could have said M prime, okay, with K equal to 2 in this case. All right. Remember, and in the notes, it was kind of a general, but regardless, it's always new divided by old. Okay. Let me do a quick example here. Let's pretend this was length Z, and let's pretend this was length W. Okay. What would be your dilation? Well, it's still just new divided by old. So if you said dilation with a scale factor of W over Z, you'd be absolutely right. New length is W, old length is Z. If I multiply Z by W over Z, don't the Z's cancel on the left with W? Okay. So don't make this complicated. If it's a general question with general lengths, okay, in this case, of course, it was x or y and 2y, which made it a little bit easier. But think about it. What do you have to multiply y by to get 2y? Well, 2. That's why the scale factor is 2. Okay. If you have any questions, of course, you can come and see me Thursday morning. I'll be in room 102 before first period. So come by and ask me anything you need. Have a great night. I hope this helped. Study hard.